Greetings, everybody. This is Eric Andelin, Senior Workflow Advisor with SimActive, and you're joining us for the workshop Managing Large Photogrammetry Projects with new Correlator3D version 10.3. And with me, I have my guest speaker, David Alamillo Photogrammetry Specialist with SimActive. David, other than that ugly Patriot sticker, say hi to everybody.
Good catch on that. Good catch on that. I know we suck this season. Yeah, hi everyone. I hope we do better next season. This season, actually, you know what? While we're at it, we should place a little bet out here, Eric. Who's taking the Super Bowl this year?
Three-peat, man. Three-peat.
Okay. You're going with Mahomes. Sounds good, man. Sounds good. I'll go against you on this one, and I will say I'll go LA. How about that? We won yesterday. It was a very good game.
Yep.
So I'll go Rams.
All right. Well, there we go. So, David, at this point, I mean, everybody knows who you are in the SimActive world, but go ahead and introduce yourself for those who aren't.
Sure. Well, thank you, Eric. Name is David Alamillo. I'm the Photogrammetry Specialist for SimActive. Oh, wow. Been for the company now 3 years. They've gone so fast and really happy. I just celebrated my 3rd anniversary just a couple of weeks ago. And again, for the folks who don't know me, I'm in charge of success support. We probably met doing demos as well with any of the sales teams. So I help during the sales process, help understand the software, workflows, and also when you guys run into any issues, I'm the guy mostly answering all the questions. Of course, I want to highlight, Eric, it's a team effort. I go to you, I go to Thomas. Thomas is also one of our photogrammetry specialists and R&D team. I mean, we all do a great job, but and most of the times you hear from me, but it's a team effort for sure.
Yep. Very good. So today we're going to talk about releasing version 10.3. We're going to cover some of the these basic topics, which are preparing to process large projects, best practices for success, speeding up processing with multiple PCs, and then finally, a recap of the new features in version 10.3. In the drone world, a large project might be a square mile, but it might be 10,000 images. In the aerial world, which is where we came from, in the large format world, that might be an entire state or an entire country or something like that. So each has its challenges, but 10,000 images is 10,000 images, whether it came from a small camera or whether it came from a large camera. Clearly, you've got to have a quality PC, good GPU, all that kind of stuff. What are some of your thoughts on preparing for a large project? Now, we know that the pilot's going to go out and fly it. We can give advice on that, and then just how to manage and get all that stuff ready to bring it into Correlator3D.
Yeah, it's an excellent question because it's two-tiered, right? We got folks who receive the data from the pilot, from the operator out in the field, and gets all the data. He has no type of input on how the data was collected. And that's a lot of the cases we run into when they already have the data in the office. They're like, okay, now what do we do with all this large hard drive that they obtained from the operator? And then the other tier, which is easier, is when you're able to manage or have a team where you can input. How do you want the data, first of all, parsed and organized? Do you want it by flight day? Do you want it by, I guess there are other options too where you can break it down into just simple areas, flight lines, AOIs. So when you have the ability to input this information to your operator, things, I guess, flow a little bit better and faster because you know what you basically have an expectation for the data coming in, and that expectation is met. So you're ready to start. And in preparing for that, of course, you talk about overlap, you talk about altitude, you talk about AOI, you talk about, how many days are you going to be out in the field flying? When do I expect to receive the data? So it's better planned. When you don't have any of that and data comes into the office, you're like, okay, let's start by opening, and this is part of the prep, right? Opening the hard drive and seeing, and if I need to copy all this information into a dedicated server, or sometimes simply copying into my local machine. So I think a very important part of the process, and this is exactly where it starts, is how am I going to manage this data and where is it going to be located? Where can I store it will be the fastest way for me to process the data without having to, copy 16 terabytes of data in the case of processing a country. So I guess this is one thing that I bumped into a lot, and folks ask me a lot this question is like, do you prefer to work local or do you prefer to work on the network? And part of the preparation, I think for me, the first step is to determine that. If you're going to use multiple machines, distributed processing, or just a single monster PC who's going to process all the data, you can leave it in a dedicated local storage, or you can actually work in the server and put everything there and then pull from the server. Of course, both have their advantages and whatnot, but I think from a processing perspective, I would say that's the first preparation step that I recommend thinking about and analyzing how you're going to manage that large data.
Well, and you mentioned sometimes you just get a hard drive with the imagery because somebody else collected it, and there's nothing wrong with that. In fact, back in the day, you had aerial photographers that did just that, and then you had mapping companies and surveying companies that did the mapping. They trusted the aerial photographer to capture it in a way that was usable and proper for what they were trying to do. Now sometimes we have hybrid situations where that company is now a geospatial company, and not only do they have aircraft, but they might also have drones. So it may be a little bit more controlled in-house, but you get a mix of both. And I guess the first thing I would comment on is when I get that hard drive, I open it up and see if there's any EXIF information. Did they include all the files that needed to be included? Yes. In this whole data set, so that we can actually start bringing it into processing. And then, like you said, do you want to process it locally? Do you want to process it on a network? And that really depends on the size of the project too. If it's small enough, you can just rip it, pretty quick locally and all that. But once a project gets big, then the average person doesn't have that workstation that can handle it, at least in one piece. So you start talking about doing it on the network and things like that. You also mentioned storage space. So do you have a rule of thumb for how much storage space you need? So if somebody gives you 5 gigs of data, how much space do you actually need? Because we know software is going to take that data and do things with it and require some space.
Sure, man. It's an excellent question. I like this usually, I end up showing this in the demo because we get the data from the customer, and sometimes it's 200, 300 images, and for something that small, you mentioned, for example, 5 gigs, that could. And there's a specific step, probably I should mention this. There's a specific step where you generate the most amount of data. Those large, huge files, you're like, whoa, this is impressive. And it's the ortho rectification. Mm-hmm. All those tiles, they generate quite a large amount of data. And there is an option in Correlator to do a compression, JPEG and TIFF compression at that specific stage. And I always recommend looking at this step because when you're going through the automated workflow, you don't have the option to compress in the automated workflow. However, you do in the script mode, and you do when you're going through the GUI, right? So if you're going module by module, you open the ortho rectification module, you have that option there. And here's where a project, if you don't compress, can blow up to 30 gigs fairly easily, going from 5 to 30 gigs if you don't compress. Well, if you do compress, you're looking at about, I would say, 10 gigs, of ortho sometimes. So you double that number. But going from 5 to 30, a lot of folks are like, "What blew up my hard drive?" I can't imagine the feeling there because, you immediately run out of space. So that is an excellent question. So compression, no compression. I'll finally add, some folks say, I'm not allowed to use compression on this job. The client said no type of compression. Mm-hmm. And in that case, yes, you're going into the fact that you're going to run a large project. It's going to create tons of, ortho tiles, and they're going to be quite big. So you have to expect that.
Yeah. When you compress things, you really start, in the end, it's a small data set, but as it's doing it, creating pyramids and things like that, it really starts to absorb space. So you have to be aware about that. The other thing was, available workstations. Do we even have a a rule of thumb as far as what you need for a PC, and then in building networks?
Yes, we do, and that's something that changes. Because hardware is changing,
Yeah.
by the minute. So we always have new, better GPUs. I'll have to say that the main component for Correlator, we're GPU based. We're a GPU based software, so your GPU plays a super important role in the processing. I'll give you the model that I've been running internally, but I've talked with R&D. I've talked with other folks as well who've been doing upgrades to our machines. So I have an updated GPU that we can recommend here online. And the other component is NVMe SSD drives.
Yeah.
Those two main components are extremely important. And I guess I'd say the GPU is the most important component, but right underneath that is your storage, how the software is reading and writing those images. So it's very important to consider these two topics. And then we talked about RAM. I have to say, when we talk about RAM, talking about 16 gigs of RAM should be sufficient, for the process, even for a large process. And CPUs go from from i7s to i5s. I'm running an i7 on my PC, and it's running perfectly fine. Intel's run great. So I would say I'm not too concerned about the CPUs, but definitely about your storage and your GPU. And if you allow me here a second, I'll pull up the GPU that we will be recommending. And like I said, it's been like a month ago that we talked about this topic, so it's pretty fresh. I'll let you know exactly what we're recommending. For processors, i7, i9, we even went a tier up. i5s are now obsolete. Minimum of 16 gigs of RAM, maximum of 32. And we're recommending the NVIDIA, the RTX 4070. The price is pretty competitive. And I would say this is one that we don't have in the office, but we'll definitely looking at and to acquire for our processing machines internally. So again, for the folks out there, NVIDIA RTX 4070, very competitive. R&D said, this is the one. If you guys are browsing for something or trying to purchase an upgrade, it's a good option. And then SSDs, I think we said NVMEs, generation 5. That would be the standard there.
That's good to know, because I went out and bought I bought a laptop recently, and it hits all those. Lucky me.
You didn't reach out to R&D?
Huh?
You didn't reach out to R&D for recommendations? You were like,
no, I knew I needed an NVIDIA card. I knew it needed to be in the 40 range. I went with 32 gig for the memory, and it's an i7, so it works out. I'm not processing 10,000 images, but I can process 5, no problem, on my laptop. So, but interestingly though enough, those are pretty basic rules to go by, and honestly, it's because Correlator3D is GPU based. I was looking at another software the other day that processes imagery, and I think the guy wrote a thesis on what kind of RAM you needed and what kind of CPU and all this, and it turned out what he was using was not a GPU, was not a software run by GPUs. So it came down to he was building a farm to process imagery, and I was like, that's kind of crazy. And I guess if you want to do that, you could do that, but we really make it easy. The GPU is important, and the data transfer is important through the SSDs. That's it, and then you can process. So that's good to know. So that kind of covers our topic of preparing to process large projects. We can get in a little bit more, I guess, about just simple things like file structure. Have a standard file structure set up so that where in Correlator3D itself it'll create a file structure. It'll deposit all the pertinent information into those files. You'll always know they're there. But you may also want to bring other things in, like shape files to cut your data or something like that, know where those are going to be, and make it homogeneous so that every time you do a project, they're in the same place. So I would say that's the only other thing I can think of.
Yeah, exactly. Oh, you know what? I have one last comment on the GPU. And I've noticed this. It's the firmware updates on your GPU. For folks out there who have automatic updates on most of their hardware, great. If you don't, it's always worthwhile checking what firmware version you're running. Correlator is really good at identifying this, and it will throw you a message in the log saying your GPU might be outdated. It will diminish the performance of the software. So it just takes 2 seconds to go to the GPU manufacturer and make sure you're running the latest firmware on that GPU. Sorry, I forgot about that one. So anyway, back to the file structure. Yeah, it's extremely important to have everything in one place. I'll have to add the projection also when you're bringing in shape files. In most cases, there are sometimes shape files that were added to the folder and you're like, hey, but these are not working. And I've done that myself. I'm guilty of that. I'll drop in a shape file and it's like, it was supposed to crop this thing. Why didn't it crop it? And before I start, talking about an issue with my data, I was like, oh, it's not projected to the specific area where I'm working at, right? So it's something that I've learned the hard way, but always now, every time I receive an LAS file that's from from my LiDAR team, or a shape file, like crop it to this extent, or your tile definition file, I always make sure that everything is in the same projection. I was like, okay, great. We're ready to start. Everything is in the same projection. And also take the time to organize it, right? So I know, like you said, receive a hard drive, and then I was like, okay, here are my raw images. Or if you're processing nadir plus obliques, you're like, okay, nadir's in one folder, obliques in another, LiDAR in another, shape files and crops and everything on another folder. So I have everything as organized as I can. So yeah, that's an excellent point, Eric.
Yeah, and that leads us into our next topic, which is best practices. Even as simple as that. Best practice, open up all those files and make sure they're in the same location before you finish your job and then go to tile or whatever and can't figure it out.
Yeah.
Do it while it's fresh in your head when you're setting up the project, not, 2 days later or a day later when you're trying to export something in a hurry for your customer. So best practice for okay. So let's again talk about bigger projects. And small projects, you can just load them. It's always our recommendation to do a sample within the data set to make sure everything's right in the way you want it before you go ahead and process the whole thing. But with larger projects, there's even more to it than that, or there are more things you can do to ensure that you're going to have a successful result. So talk a little bit about, what you might want to do large project versus a small project.
Sure. I guess something that applies to this is divide and conquer. I think that's a rule of thumb I always had. And when we're talking about large projects, that's like my banner right there. Regardless of me being able to process everything in a single batch, I always like to remind folks there is a QA and QC process throughout the entire project, right? And you don't want to be doing this as a last step, because then you're finding stuff that will require you to reprocess things and try to merge things. And it becomes a pretty messy deal. So I always like to remind myself, even though I can process 24,000, 25,000 images in one single batch, I'd rather, in the process, how it goes, I like to process the AT on the 24,000 images. That I do. I run my tie points, I run my bundle adjustments, my GCP tagging on everything. But when it comes to the secondary process of creating your DSM, orth rectifying, mosaicing, I like to do it in batches. And I like to see how the DSM turned out for a very small portion of the data. So I will disable the images on my project tree and just leave 200, 300 images. And, sometimes when you're looking at the data, you notice, you have the satellite background image when you load up your images in Correlator. So you kind of know difficult areas already in your project. So you're like, oh, man, this is over water, very dense forest. And you have like the worst combination and plus snow on this area. So you're like, man, the worst area ever. And you already know what you're going into. You already know your tie points were kind of not as full as you wanted to. I like to take that area, 200, 300, 400 images, and process that as a single block. And like I said, the only thing you need to do after your AT is done is disable the images in the project tree, and then leave those 200 images. It might be 6 or 7 flight lines, and run your DSM. Look at the DSM, look if you have any elevation issues in there. Maybe you need to go and redo your AT and add a little more tie points to that area to strengthen the area where you need a little bit more coverage on the DSM. So that's an important part of the process. Like I said, divide and conquering, it's crucial for these type of large projects. And then once that looks acceptable, I was like, okay, the rest is a piece of cake. I know I have a strong AT on the entire, the rest of the project. I can go in, securely run the DSM for the entire 24,000 images if need be. And I still like to divide it, Eric. I'm always of that nature. It's like 24,000, let's do batch 2,000. And this is where I get the comments, and we're still talking about large data sets. It's like, man, and do you sit in like enable 2,000, disable 2,000, enable 2,000 in the project tree? I was like, you could. But here's where scripting comes into place, right?
Yes.
You can script process, and you can script the software to do batches of 2,000 images to run your DSM. And this is where like, oh, wow. So it can do it in batches. Yeah, absolutely. And you can review the results of those batches and then see if, there's anything wrong with it. You can merge all those DSMs at the end and create a massive DSM for your 25,000 images. So I think that's a great way to start. With small projects, on the contrary, yes, you're doing everything in one batch. You're running everything in one batch. Even then, I might use that approach that if you have a difficult terrain, difficult area, run that small process. It might be even 100 or 200 images, on a small project. Just see the results, see how it looks. You might have to go back and do some tie points, but that will ensure that the entire project is not hanging, on that specific area.
Yeah. One thing I would add to that is when you have a small project, and we all know that you overfly your projects, those images that you don't need tend to be a small percentage. It may only be 10% of the project, of the image, 10% of all the images fall outside your project and you don't need them. But when you're doing 25,000 images, that's 5,000 images maybe that don't need to be in your project. So you can use Correlator3D to clean those up, and you should consider that. And then you talked about the batch processing, and sometime last year or the year before, in one of our version updates, we added the email notification and the ability to text notify yourself. So, when you spend all that time scripting and creating those big batches, it's really nice to know, via your phone, ding, oh, yeah, DSM number 1's done, So you don't have to sit there and babysit and look at a monitor during this whole process. You can just let the software notify you when it's completed a project, which is pretty nice.
Excellent.
Yep. And then we talked about sampling or doing a test sample of the data set. Another thing is tiling and mosaicing. So you can break a project into tiles, and you can process that project. And people say, but wait, my mosaic won't be color balanced. Well, that's not true. You can then, and through scripting, bring those mosaic tiles back in as orthos, and then let the software rebalance it. So again, we're talking about big projects here, not the average, land development site, but I'm mapping, the shoreline of California or something like that. So for our clients that use it at that scale, and they tend to be a little bit more bespoke in how they do things, scripting, batch processing, those are the things that get them through those processes.
Yeah, absolutely. You're absolutely right. Sometimes when we talk about the word scripting, myself included, I would get a little nervous, right? Because like, oh man, I didn't study coding, or I didn't go to computer science class. And then when you discover that the software generates the script for you, and that it actually lists all the steps, and you have a guide, we'll get to that part eventually, but you have kind of a template of what things you can script. Like, well, this is not that complicated. It's kind of copy pasting into a document and then telling the software, do this.
Yep.
And the software will actually take this. Now, of course, that's the basic of it, which, once you grasp it, you start building on it. But on top of that, YouTube tutorials to teach you how to do a Python script in this case, you might be able to take 2 or 3, 4 projects and daisy chain them and have the software process all those with all different cameras. It doesn't have to be like the same camera, the same area. It can be totally different area, totally different sensor. The software will take each and one of those separate, with its own calibration file or own EO file, and then process that into its dedicated output. So for folks out there, don't be intimidated by the whole scripting word and, that's too complicated for me. No, it's actually, I would say, pretty easy, but you just have to pay a little more attention to detail when you're copy pasting those commands. But once you do it at least 1 or 2 times, you'll get the grasp of it and just start like, yeah, all I'm going to do is scripting now.
Do you want to show your screen and show where those tools are?
Sure,
okay.
Absolutely.
Go for it.
Let's go ahead. Awesome, perfect. So as I was saying, where are all those templates located? I'm highlighting right here the location of them. You go to C, Program Files, SimActive, Correlator3D. A lot of folks don't actually navigate through this process because they think it's a program file and you don't want to mess with those things or you might ruin the software. Well, the reality is that we actually include a lot of information in this particular location. And if you guys are following my mouse, there is one particular tool here called the Convert EO tool. A very important one. This is heavily used during scripting, so we're going to highlight this guy. And the other important tool that we're going to talk about, and I mentioned, is going to be in our sample files. So we're going to go to the folder location, and you'll see here sample files. So if we go here, the path, if you want to go directly to the path, will be C program files, SimActive, Correlator3D sample files. And we have a couple of folders here, Eric, starting with the camera calibration. We have these templates for your camera calibration for every single mode that we have. Digital distortion tables, digital polynomial scan films. And this is, of course, depending on the camera. If you have a metric camera, you probably want to go with your digital calibration, right? If you have distortion tables, you want to use the distortion table one, or if you're most likely flying a drone non-metric sensor, you want to default to your digital polynomial camera file. Let's open it really quick so we can show it here on the screen so you can see the values that we can input into it. Image width, height, focal length, principal points, pixel size, your KMPs. Typically, when you probably guys notice when you're loading up a new project, you only need your image width, height, focal length, and pixel size.
Yep.
If you're doing the calibration in the software, we will obviously output this information and run this when we're doing your bundle adjustment. So that's a very important part of the scripting process. My apologies, I went out here. And let's go back one and go to the script. And in the script, we'll open up this SPT file. And you can see here, it's basically a template, right? We have everything the software can do, all the operations listed from 1 to 20, from aerial triangulation, DSM extraction, DM merging, so you can even do the merging as a script file, and then all the steps for each and one of those. I want to highlight one that we talked about earlier, which was the ortho rectification. I mentioned you don't have this option in the automated workflow. However, you do have it in the script. And in the script, it's a simply copy paste. You can see right here, it's the JPEG in TIFF compression. So it's a simple copy paste into the script that you're going to be processing. So you only copy this and paste it into your script and to the script you're going to be using. So with any of these operations, you can simply copy paste, and that would basically copy the operation into your script and ensure you're actually running that. So all this is located in that folder. Again, very important for any of the processes we're running, but you do have those tools available for you to look at in the program files section. So again, one more that we're going to talk about here is if we go to the script, let's go actually to, most folks ask me, like, how do we initiate the generation of the script? And that is done in the software. Perhaps I'm going a little faster now, but let me know if we want to look at that for now, or maybe
no, go ahead.
There's something else.
Yeah, no, go ahead.
Awesome. Let's get Correlator started, and we're going to cancel for now. Let's get Correlator started. We're going to open up an existing project, and we're going to go to our handy dandy Tampa LiDAR data, which, Eric, did you process this data set? Did you collect this data set?
Actually, yes, the LiDAR portion came from the county, which was under contract to have that data set created. The imagery and all of the rest is something I collected from a previous company.
Nice. Yeah, this is my go-to.
Yeah.
It's such a nice data set that's small, compact, and you can see everything really good.
Yep.
So I use it a lot. So thank you for that. I'll show you guys how to generate that script. And you will go to your automated workflow. And for folks who know this, they'll see that they have all these options here at the profile section to change all the settings they might have on that specific project, right? All the way from if you want to do a true ortho, we'll automatically change that to output a true ortho. We'll go again with classic photogrammetric. And even here, you might want to do changes. Let's do the extraction type. We're processing dense forestry, and we want the software to do an exhaustive type point extraction. So we adjusted the setting, and we'll leave it like that for now. At the bottom, there is an option to generate the script for this specific project, right, with the settings that we've already changed. So we're going to switch this to on, hit process, and we're going to bring in that SPT file that was generated for us. So here we go. And we can immediately notice that the changes we've made as far as in the GUI, they're automatically made in your script file. So you don't have to update this. You see the extraction type is exhaustive, as we noted. And just to give you an example, on the orthorectification, I don't have a JPEG and TIFF compression. So that means as small as this data set looks, it might output a good 10, 12, 13 gigs, on the orthorectification if it's not compressed. So back to our previous option here, we can actually go and copy from the script, right? Remember, we were here in the orthorectification process. And I'll show this one because this is one of the most popular ones. Copy the JPEG and TIFF compression, and then go back to our script. Open a space, and we'll basically just align it there for sake. So we'll align everything up. JPEG and TIFF off. We want this to be on, and we're ready to compress everything. So it's as simple as that. We can save our file. We can save it in a specific location or project, or we can simply save this file that was generated for us, which is going to be in your project folder. And then once that's done, it's as simple as coming to the file section. If you don't want to run command prompt just yet, you can run it from your GUI, run script. Yes, I want to continue. That will close my project. And then I can basically browse for the SPT file. Like I mentioned, it's going to be in my project folder out here, processing, Correlator3D, project, and open, and that will start the process. It's really as simple as that, right? I could have made more changes in that to output, export, everything I had on my template. However, I just needed that to be processed, and that's it. But you have several options in your script file for the mosaic creation, adjusting your feathering size, your color balancing, yes or no. If you want to export the mosaic, you can export it right from the script as well. So again, it's very intuitive. As you saw, it's very easy to use and generate the initial script. So that's, I would say that's easy mode. Check. We got that done. Yep. What do you think, Eric? I know you're an expert too at this. Anything I might have missed?
I would say I'm absolutely not an expert at it. I'm like you. I didn't go to school as a programmer, but I can certainly find my way around to generate scripts. And in fact, I did one for a large project where I broke the project up into 4 tiles. I created a script for each one of those tiles. Actually, it was the same script. I just had to rename the folder that it was pulling the imagery from.
Yes.
But then I also, with the help of Thomas, created a batch file to open Correlator3D, load that script, and run it from the command prompt. When it was finished, load the next script and run it as well. And when it got done with all of them, merge them all together. All from the command prompt. So you certainly have the ability to do that within Correlator3D.
Absolutely. That's a great point. Yeah. Thomas, I have to say, he's a guru when it comes to Python scripting. I've gone to him for some questions. And speaking of that, we have a great quick start guide that, of course, Thomas helped assemble, and he ran through it himself and ran it. So let me show you guys where that is. It's in your reference documents in basically in our website. So you guys can look at that. I have it on screen right now, but you guys can see it's basically our quick start guide for running Correlator3D via Python scripts. And that's exactly what Eric was talking about. It gives you all the, the Python installation you need, where to find it, EXIF tool, which is amazing. That's one of the amazing tools that we have in our community. And, all the options you need, right? The EXIF extraction, you need that EO file. We talk about how to get that EO file, how to get the calibration file, and the script file. We basically talked about these two during this call. So you already have your camera calibration file, at least the beginning. You know where to get it. You know how to generate your CTG script file. So it lists basically all the steps. I like to remind folks, step 6 is a crucial one. This is the one where you'll be doing exactly what Eric was talking about, is just creating your script for those individual steps. Or if you want the software, use your Convert EO tool. And then you can daisy chain 2, 3, 4 projects. It could be within the same project, process maybe batches of 1,000 images, and then export them as well. So step 6 is extremely important in that process. But we do have a very great, I would say, starting guide that you can reference and go step by step. On top of that, there are several resources now. YouTube is like YouTube University to the rescue. So many tools on YouTube as well, where I find scripts, and most recently, ChatGPT University.
Yep.
It's truly amazing. You tell, hey, ChatGPT, write me a script for Python to process, 3,000 images, and you give them, the options that you want, and Python will give you a great skeleton of doing that, ChatGPT in this case. So I would say, folks, if you haven't tapped into that, it's perfect time to start just throwing in some basic questions, and you'll see it's quite amazing as well.
Yeah. Well, that's that covers that topic for sure. The last one we come to is speeding up processing with multiple PCs. So talk a little bit about distributed processing, maybe just some ideas of how it gets set up and what you can do with it.
Sure. As the name states, it's such a powerful tool that we have in our arsenal. Some folks are already running 2 or 3 licenses during a month. And I would say the main requirement for you is to have all those licenses talk to each other in a network, right? That's the very first step. So they need to be discoverable within the network. And the next step is to have quite a robust, I would say, network setup, at least to read and write those images from any given location. So that's, I would say, the number one thing to take care of, and that I see the most folks as, my network is not very robust, and that everyone is tapping into it. Someone's like doing heavy processing with other softwares. So I would say the more robust your network is and the connections to the network, the better the software is going to perform, right? So it really depends on those reading writing speeds. So I would say we do have some basic starting points on your network. I'll basically try to find here the page really quick, but I think we can show folks a little bit of what the requirements are as far as what we have in our website. And then obviously setting it up, most folks rely on the IT team to do this. Yep. They're like, you know what, David, I don't know how the network's set up, but if you can talk to the IT department, that would be great. And it just takes simple.
I would say we don't need to get that deep into it, because if somebody's going to start doing distributed processing, they're going to be in contact with you guys anyway. Would be my guess.
Yeah.
But in Correlator3D, can you show them roughly where that's at and how it's done?
Sure. The first step you're going to run is when you're installing the software, you have an option to do that right from the starting point when you install the distributed processing service. So some folks ignore it completely when they're running through the installation because they don't have the need for it. But of course, if you do run this, you can basically see the installation of the service. It'll literally prompt you to say, would you like to install the service? You can type in your information for your network, and that's it. That's really all that the software requires. What about if you missed it? We can go back to the options here to see what happens if you miss it. And again, in our website, we have all this information regarding the network requirements, 10 gigabit PCI Express card. So simactive.com/distributed processing, you'll find those for your IT team. But if you go to Correlator, you go to the file section, run all the way to your general settings, and here you will see that the network service is not installed. So this is where you want to start, right? You have your network adapters, you have your groups, and you can initially start that process right from this. In our case, of course, I only have one. This is my local PC, so I don't have a network set up to install it. But in our processing machines, we do have this service installed, and it runs right from the installation process. So if you don't know this information, you can always prompt the IT team and say, hey, guys, I'm installing the software. I want it to be part of the network because we have 2 licenses, and that is the first step. Now, perhaps we can tap into one of our processing machines that you guys want to see how it looks once it's set up. Would that be useful, Eric?
Yeah, that would be helpful.
Let's do that really quick and tap into one of our processing machines. You guys can see how that looks once it's set up and how to find the machines as well. Once you have the 2 licenses, like, okay, now how can I find the next machine in there and allow it to help me in the processing? So we have.
While you're doing that, the one thing I want to point out is that if you're running distributed processing, you're going to experience between 2 and 5x processing gains based on how many additional PCs you're tapping into. There is a law of diminishing returns, so at some point you can't really put 20 PCs on something. You're not going to see that much gain on it, but certainly up to 5, you'll see speed. Now, granted, we are the fastest out there. And so you're just going to make it even that much faster, which is great. Sometimes, again, when you're mapping or processing very large projects, those gains make a difference. So we'll just keep that in mind as David brings this up onto one of the network machines, so that we can see where you would see that reflected in Correlator3D.
Perfect. Yeah, absolutely right. And I think between 2 and 3, I've done tests here in the office. We have 2 to 3 machines that have run distributed processing. Mainly 2. The main 2 processing machines we use, as you guys can see, it's Red Stripe. And what we're going to find our other station right here called O'Keefe. So right here at the bottom, you see the processing station list. If that's not there, you can always find it here as well in the view section. So to display the processing stations, if they're basically, you're seeing the properties, but you're not seeing the processing stations, simply come to view, click on processing stations, and then you can see my local is ready to go, but O'Keefe says it's busy, Eric. And I'm guessing that's you. No, I'm kidding. I'm guessing that
I
might
always
be
leave things open. No, it's not me. But that's the important part, is for people to see that, because again, you may own multiple licenses of Correlator3D, and you may have those because you've got different groups processing different things. But sometimes when you run into a big project, you can say, you know what, I'd really like to pool all those and shovel off tasks to a different workstation. And this is the way you do it.
That's right. If you need to add a processing station, you can type in the name of the PC in the search bar. It will find that PC based on the name. Or you can type in the IP address as well, and it will identify that PC. And not only that, but you'll see the status. So what happens if a station is busy? I mentioned Eric because whoever's using the other station, you can communicate to your folks and say, hey guys, I'm about to run a distributed processing using that PC, or you guys can free it up. Yes, sir. They need to close Correlator3D on that PC, so completely close it. And then you will see this updated to ready. And Perfect. If they've done it already, you still won't see it ready, simply refresh the list, and it will refresh the status also of that particular machine. So again, very important. We simply enable this, and it will start running the project. One more thing, Eric, regarding this and the setup. When you're starting your project, make sure that your images can be read through the network, right? So in
Yeah.
this case, if we're running a project, they can't be stored locally because the other machine doesn't have visibility or access to your local folder. Therefore, they need to be stored in a location where both PCs can see the images, can pull the images, and can read and write. So that's one main thing. It has to be, well, here we can see we're pulling them from the network, KEG. See the double slash right there. So that means we're going to initiate our process from the network. So when you're importing your images, import from that storage location. Another important thing, and this one is regarding your general settings and your temporary folder. I don't know if you've gotten a lot of questions about this one, but I have for sure. Where it says like, my temporary folder is stored in my local drive, so it's filling up so quick that we don't have any more space. And very important to update it. And the way you can do it is File, General Settings, Temporary Folder, and you can see my temporary folder is in the network on Red Stripe, but I have a pretty large dedicated C drive for this particular temporary folder. If not, you can always move it. Go to the three dots and move that temporary folder to a location where all PCs can read it. That's very important. They need to read the temporary folder. If not, you're going to bump into issues. But I guess from that point of view, you can see on this case, you get to see the network service running. And that's the important part here. Make sure that the service is running. Make sure a temporary folder is available to all PCs that are going to be doing distributed processing. And you're pulling images from that folder location where everyone has access. So that would be my main keys, I guess, when you're running distributed processing, at least for the first time.
Very good. Very good. So, so we've talked about, and we're going to hit one more thing in here before you give back the screen, but we've talked about managing large projects in version 10.3, and you were talking about version 10.3. So what's new in 10.3? And the answer to that is a lot is new in 10.3, but it's there for you and the user experience more so than, for example, a feature. In other words, we've sped up some of the things that are going on behind the scenes, like loading imagery, which means the software has to read headers and things like that. And when you're dealing with a large project and you see a progress bar and you watch that progress bar slowly creep as it's doing its work, in a large project, that project bar or progress bar might seem like it's not moving. Well, it is. And what we've done is we've made sure that we've made enhancements so that you, the user, are more aware of what's going on in the processing as it's going on for larger projects. So when you process a larger project, you'll certainly see that. But we did add one feature that has been a user request, and that is adding the ability to incorporate geoids. So, David, a little bit about that.
Sure, absolutely. As you said, it's a good request, and we've had it for a while. So right here I have Correlator open. I'm about to import my images, so it's asking for my camera configuration. Let's go through it, guys. So I'll show you exactly where that is. We'll add the folder of images, and we'll default to our handy dandy LiDAR Tampa data set. I'll say no. And we have our image imported. And if you go to altitude geoid offset, that looks very familiar. But if you drop down the menu, you'll see geoids that are available for you now, going from EGM 84, EGM 96, 2008, or as always, you can edit, right? So you can enter the value manually. So you guys are pretty familiar with that tool. If you need to offset the image to a specific, not geoid, but altitude, you can import that as well, just as you did before. But here they are, folks. Now they're ready to go, ready to rock. So yeah, that's a good starting point.
So now you don't necessarily have to go outside of Correlator3D to one of the websites to figure out what your geoid offset is for that specific location you're working in. You can just plug in one of these and it will go ahead and calculate that out for you.
Absolutely right.
Yeah. So that's very helpful because not always do you get that information correct. And you again, start with a small sample of your project and you say, why am I 32 feet off consistently? It's probably your altitude offset. It wasn't included in the EXIF information, in your positioning information. You're going to have to add that in. So obviously nice to have.
Absolutely. Absolutely. So for all those folks asking for it, it's right there.
Yeah. So with that, I mean, we're to the point of concluding this webinar. David, you can go ahead and close the share screen.
There we go.
Yeah. So again, we've covered everything as far as preparing to process large projects, best practices for success, speeding up processing with multiple PCs, and new features of version 10.3. Again, under the hood a lot, and with the final added feature of your geoid ability. So that stuff's great. David, I always appreciate talking to you about these things. You and I do it on a daily basis. So sometimes we don't slow down to think about it. We just do it, or we help the person in need who needs it done. But it's great to have a meeting of the minds because some of the things you say, I take to note and I remember them for our users. I'm sure it's fantastic. I mean, they're basically getting a free, a free visit with our support and tech geniuses back here. So that's always good. Any more comments, David?
No, thank you so much, Eric, for inviting me. It's always a pleasure being with you. And like I said, team effort, learning from you, learning from everyone in our team. And that's the beauty of it, right? Everything evolves and we're evolving at the same time. So no, thank you so much for inviting me.
Yeah. And to our users, again, if you have any questions about this webinar, go ahead and drop in your comments. We will respond to them as soon as possible. We appreciate your joining us for this. And remember that we have a knowledge base full of information on our website where we've got case studies, tutorials, videos, everything you could think of to get you through any issues with processing that you have. And if it's something unique, we also have a users forum, don't we?
We do. The community forum as well. If you guys want to post in your questions in there. And on top of that, I like to highlight our training packages too.
Yes.
So if there's something that you guys would like to have a one-on-one or us review a specific data set you might have any issues with, you can always reach out to our sales team and we can quote you a training package as well for you guys to take advantage of those offerings that we have.
Yeah, and I'll be honest, I've been a part of a few of those training packages. So if you want to see me in person, there you go.
There you go.
Other than a conference or out riding my bike or something like that. That's how you get a hold of me. Again, David, thank you for joining us. I really appreciate it.
Thank you, Eric.
Well, I'd like to thank my guest, David. Thank you, David. I'd also like to thank those that attended the webinar. Again, if you submitted a question during the webinar, I'll make sure to get those answered for you as soon as possible. I'd also like to remind everyone that this webinar, as well as all of our previous webinars, are available on our website, simactive.com, where they can be found under the Learning tab. Additionally, this webinar will be converted to a podcast and made available in the next few days. Thanks for joining us. Until next time.